a discrete time system is given by the system function h of z is equal to 3 minus 4z inverse 1 minus divided by 1 minus 3.5 z inverse plus 1.5 z inverse square. Specify the ROC. We need to specify what is the ROC of h of z and determine h of n for following conditions. First condition is for the system to be stable and for the system to be causal. So for system to be stable, all the poles should be inside the unit circle, and for the system to be causal, the ROC must be outside outermost pole. So given equation, three minus 4z inverse z inverse plus 1.5 z inverse square. So this is the h of z given. For this, we need to find out the region of convergence and h of n for two conditions. One for stable system, another for a causal system. Okay, so let us first simplify this using the factorization, that is 3 minus 4z inverse divided by, if you put this into calculator and apply the ax square bx plus c, that is quadratic equation formula, you will get that it is 1 minus 1 by 2z inverse 1 minus 3z inverse. These are the factors you will get. Okay, so by this only you will come to know that there is a pole at 1 by 2 and there is a pole at 3. Okay, so since we have been asked to calculate h of n for different systems, that is stable and causal, what we have to do, we have to apply partial fractions and solve it and then take the inverse z transform. So applying partial fraction, this will be a1 divided by 1 minus 1 by 2 z inverse plus a2 divided by 1 minus 3 z inverse. Okay, so now 3 minus 4 z inverse is equal to a1 into 1 minus 3 z inverse plus a2 into 1 minus 1 by 2 z inverse. Okay, so now if you substitute z inverse is equal to, say, 1 by 3, z inverse is equal to 1 by 3, what you will get, 3 minus 4 into 1 by 3 equal to a1 1 minus 3 divided by 3, so this is 0 plus a2 1 minus 1 by 2 1 by 3. Okay, so finally if you solve this, you will get a1 is equal to 1, sorry, a2 is equal to minus 1. a1 is cancelled out, right? So a2 is equal to minus 1. On the same lines, if you put z inverse is equal to 2, if you put that, then you will get a1 is equal to plus 1. So using that h of z can be rewritten. H of z is equal to 1 divided by 1 minus 1 by 2 z inverse minus 1 divided by 1 minus 3 z inverse. This is h of z. From this we know there are two poles. From this equation, in the previous equation also we can write the very first equation, but here it is clear that there are two poles. One is at z is equal to 1 by 2, another one z is equal to 3. Okay, how to get these poles? As I already explained, 1 by 1 minus 1 by 2 z inverse, you equate it to 0 and you will find that z is equal to 1 by 2. Similarly, you equate this one to 0, you will get the pole as z is equal to 3. So we need to now write the pole 0 plot. So 1 by 2 is here, one pole, and somewhere here another pole. Okay, and this is our unit circle. Okay, this is the unit circle, real of z and imaginary of z. So this is the very first thing you need to do. There is a 0. So this is ROC. Well, this is a z plane plot, pole 0 plot. Now uh, the condition for first one is stability. Stability. For this we need to have what? For stability we need to have all the poles inside the unit circle. That is it possible here? Is it possible to have that? For the system to be stable, its ROC must include the unit circle. So what should be the ROC? System must include the unit circle means, this point means ROC should be greater than 1 by 2, but it is less than 3. So we need to draw another circle. Let me draw it properly. For stability, the condition is ROC must contain the unit circle. Correct? For that, what are the poles? First we need to understand. Poles are at 1 by 2 and 3. Unit circle will be here. ROC must include all the poles means, ROC must include the unit circle means the condition should be this pole, ROC must be greater than this pole and lesser than 3. Then only it can include this unit circle. That's why ROC is greater than this but lesser than 3. Okay, it is greater than 1 by 2 and less than 3. So what we should say, ROC magnitude of z is greater than 1 by 2 whereas less than 3. For this, what is h of n? We have that, we know h of z is already calculated, 1 divided by 1 minus 1 by 2 z inverse minus 1 divided by 1 minus 3 z inverse. So this is right sided. 1 by 2 ಗಿಂತ ಜಾಸ್ತಿ ಅಂದರೆ this is right sided whereas this is left sided. That's why h of n would be 1 by 2 to the power n u of n minus into the brackets u of minus 3 to the power n u of minus n minus 1. Okay, ಇದು ಯಾಕೆ left sided? Because that is less than 3. That is the condition for stability for us. So we need to now write it as 1 by 2 to the power n u of n, minus of minus will be plus 3 to the power n u of minus n minus 1. This is the impulse response of the stable system. So we want our system to be stable. This is the impulse response we need to have. That is with the ROC Z greater than 1 by 2, whereas Z should be less than 3. Okay. Second condition is the system to be causal. System to be causal, what is the condition we have? We need to have ROC outside the outermost pole. So what are the poles we have? Z is equal to 1 by 2 and Z is equal to 3. So outside outermost pole means outside this 3. That is ROC is simply greater than 3. ROC is greater than 3 means obviously ROC is greater than 1 by 2 also. So both are right-sided sequences, h of n as well as, the first sequence 1 by 2 and 3. H of n is equal to, now 1 by 2 to the power n u of n minus 3 to the power n u of n. Okay, if we want to plot ROC, then this is 1 by 2 if I take, and this is 3. ROC is outside this, outside the outermost pole. Okay. For causality, no need to include the unit circle. No need to include the unit circle. If you include unit circle, then we can call it as a stable system. For causality, independently we can say if ROC is outside the outermost pole, then it is a causal system. Okay, and you can see here, if it is stable, it is not a causal, because it will become a two-sided sequence. It will not be a causal, whereas here it is a causal but not a stable system. It will not include, the ROC will not include 1, that is unit circle. It is outside 3. Okay, so it is not a both causal and stable, but it can be stable if ROC we choose for certain values, and it can be causal for some other values of the ROC. I hope this is clear.